Beneath the most populated city in the Philippines, an invisible fault waits. For centuries, it has remained silent, but silence in geology never lasts forever. Experts call it the Big One, a potential magnitude 7+ earthquake powerful enough to shake Manila to its foundations. Every day that passes, the tension builds. The question is not if, it's when. Every civilization lives with a sleeping giant beneath its feet. In Japan, it's the Nankai Trough. In California, the San Andreas Fault. In the Philippines, that giant lies directly under its beating heart, Metro Manila. Scientists call it the West Valley Fault, stretching roughly 100 kilometers from Bulacan to Laguna. It slices silently beneath schools, homes, malls, and highways. For centuries, it has gathered stress, the energy of continental plates grinding millimeter by millimeter. The Philippine Institute of Volcanology and Seismology warns that one day soon that energy will release in a single violent moment. When that happens, the tremors will ripple through the nation's capital, toppling buildings, snapping bridges, and cutting lifelines. Yet most of the city goes about its day unaware that disaster is literally underfoot. Scientists estimate that a 7.2 magnitude quake could cause over 30,000 deaths and collapse more than 160,000 buildings. These are not prophecies, they are models built on physics and precedent. The Big One is coming, but preparedness decides whether it becomes a tragedy or a turning point. Beneath Luzon lies a lattice of fractures, scars from millions of years of collision between the Eurasian plate and the Philippine Sea Plate. The West Valley Fault is part of this massive system. It runs parallel to the East Valley Fault, both forming the Marikina Valley Fault system. This is where pressure accumulates like a wound tightening over time. Scientists can map it, measure its creep, even photograph the displaced ground, but they cannot predict the moment of rupture. The last recorded major movement occurred around 1658. By geological standards, that is yesterday, yet long enough for enormous stress to build. Across history, Luzon has felt nature's reminders. The 1990 Luzon earthquake, magnitude 7.8, ripped through central Luzon and Baguio, killing over 1,600 people. It wasn't even from the West Valley Fault, yet its shockwaves reached the capital. That disaster revealed how unprepared the country was: weak structures, chaotic response, communication breakdowns. Since then, the Philippine Institute of Volcanology and Seismology has worked to map every centimeter of fault lines and urge citizens to move buildings away from danger zones. Still, cities expand. Malls rise directly atop the fractures. The clock keeps ticking. Earthquakes are the language of a restless planet. Deep beneath Manila, two giant plates converge, one diving beneath the other in the Philippine Trench east of Luzon. The collision forces energy inland, bending and twisting crustal blocks. Every decade, the West Valley Fault slips a few millimeters, storing elastic strain. When friction can no longer hold, it ruptures violently, releasing decades, sometimes centuries, of built-up force in seconds. That is what scientists mean by the Big One. A magnitude 7.2 quake would unleash energy equivalent to 32 nuclear bombs. Shockwaves would travel through soft alluvial soil, amplifying motion. In reclaimed areas like Pasay and Taguig, the ground could behave like liquid, a phenomenon called liquefaction. Skyscrapers not designed for lateral movement would sway like reeds. Power lines would snap, water mains would burst. Yet amid this science lies hope. Engineering can counter nature. Modern base-isolated buildings in Makati and Bonifacio Global City are designed to flex rather than break. The lesson, understanding physics, is the first step toward surviving it. Manila thrives above the fault as if it were eternal. Jeepneys roar, towers climb, and subdivisions multiply across the red lines on seismic maps. Many residents have heard of the Big One, yet few know whether their homes can withstand it. Philippine Institute of Volcanology and Seismology drills often show children crouching under desks. But beyond the camera, countless unreinforced houses remain at risk. Disaster experts estimate that within the first 72 hours after a 7.2 quake, Emergency services would be overwhelmed. Bridges could collapse, dividing the city into isolated islands of chaos. Hospitals might run on backup power. Communication towers could fail. Beyond physical loss lies psychological trauma. Studies from the 1990 quake and later disasters show that survivors often suffer long-term anxiety and displacement. In Metro Manila, where 13 million people live in tight quarters, panic itself becomes deadly. Yet stories from Japan and Chile prove that education changes outcomes. In communities where citizens practice drills, casualties drop dramatically. Knowledge, not fear, becomes the shield. Imagine it's 10:15 a.m. on a weekday. Schools are full, offices buzzing, highways congested. Deep below Marikina, the fault slips. The rupture travels north to south at 3 kilometers per second. Within seconds, the metropolis shakes violently. Concrete dust clouds rise as walls crack. Power grids fail, elevators stop. The quake lasts less than a minute, but that minute changes everything. The Philippine Institute of Volcanology and Seismology models show intensity 8 shaking in most of Metro Manila. In valleys and reclaimed zones, liquefaction buckles roads and tilts buildings. The Pasig River sloshes like an ocean tide. In the first hour, rescue groups scramble, but clogged roads trap responders. Social media floods with pleas for help. Cell networks collapse. Fires break out from ruptured gas lines. Hospitals fill beyond capacity. Water stations run dry within a day. For many, the only plan is survival. It's a sobering vision, yet precisely this scenario drives drills and risk mapping. Facing the worst on paper is how cities learn to prevent it in life. Not all is doom. Engineering has evolved since 1990. Seismic codes require flexible frames, deep foundations, and dampers that absorb movement. In Makati and BGC, modern high-rises sway safely because their bases isolate vibration. Japanese and Californian experts have shared technology with Philippine engineers, improving designs for bridges and hospitals. Retrofitting older structures, schools, government offices, remains the greatest challenge. Cost slows progress, but every retrofit saves lives. Architects now use performance-based design, modeling entire earthquakes digitally to see where cracks form. New materials like ductile concrete and carbon fiber reinforcement strengthen weak columns. The Philippine Institute of Volcanology and Seismology urges building owners to verify permits, not just appearances. A skyscraper's beauty means little if its core is brittle. Engineering cannot stop the quake, but it can stop the collapse. Civilization's resilience rests on blueprints drawn long before the shaking begins. Preparedness is not panic, it's foresight. Every household can act, secure heavy furniture, store emergency water, learn first aid. The government's shake drill campaigns aim to make these routines second nature. Barangays designate open evacuation sites. Radio networks prepare for blackout communication. In Tokyo, citizens keep go bags by the door. In Manila, few do. Changing that habit is as vital as any building code. Disaster psychology shows that those who visualize crises beforehand respond faster and calmer. That's why schools rehearse duck and cover routines and why offices post evacuation maps. For the big one, experts recommend households sustain themselves for at least 3 days. Food, water, flashlight, medicine, whistle. Preparedness transforms helplessness into control. It's the line between surviving and becoming a statistic. Metro Manila's geography magnifies danger. Built on ancient river deltas, its soft soils amplify seismic waves. The Pasig River divides east and west, and many bridges cross it, critical arteries that could fail. The capital's urban sprawl also means inequity. High-rises engineered to code stand beside informal settlements of hollow blocks and tin. In those fragile communities, collapse risk is highest. Yet they are also where resilience shines brightest. Neighbors pull each other from rubble long before rescuers arrive. Urban planners now reimagine Manila through resilience lenses, decentralizing vital facilities so one quake doesn't cripple all hospitals or data centers. reinforcing lifelines like water pipelines and power grids. The big one, though terrifying, forces a reckoning. What does a truly resilient capital look like? Perhaps smaller, greener, built with memory rather than denial. After every great earthquake, a nation rebuilds and redefines itself. When the 1990 quake hit Luzon, people slept in parks, shared food with strangers, and realized resilience is a collective act. Should the big one strike, the Philippines will face its greatest test, not only of infrastructure, but of unity. Recovery could take years, yet within that challenge lies rebirth. Japan rebuilt Kobe, Chile rebuilt Concepcion, Baguio rose again. The Philippines has one advantage: awareness. The fault is mapped, the scenarios modeled, the drills rehearsed. What remains is the will to act before the shaking starts. In geology, destruction and creation are two sides of the same motion. The ground breaks, and life begins anew above it. Whether Manila falls or endures depends on choices made today. The Earth will move. That is inevitable. But catastrophe is not destiny. The big one is a mirror held up to a nation's preparedness, science, and compassion. Every drill, every retrofitted school, every citizen who learns first aid bends the future away from tragedy. The planet speaks through earthquakes. Humanity replies through resilience. Manila's story is still being written, line by line, fault by fault. When the next tremor comes, whether tomorrow or a century from now, its outcome will not depend on magnitude alone, but on how deeply people have listened to the warnings written beneath their feet.